a simple linear regression is basically this formula where y equals b0 plus b1 times x. And you might recognize this formula from back in high school. It's just a formula of a trend line or a sloped line on a xy axis. And let's go through these variables and coefficients one by one. So this is the dependent variable. The dependent variable is something you're trying to explain. For instance, how does a person's salary change with the years of experience that he has? So in that case, y would be the dependent variable. Or what grade does a student get depending on how much time he's put into studying? In that case, y would be the dependent variable. So something that you're trying to understand how it depends on something else. X is your independent variable. In this case, in the simple linear regression, we only have one independent variable, so we don't even have to call it x1, we could just call it x. And this is the variable that you're assuming that it is causing the dependent variable to change, or as we will learn further, sometimes that independent variable might not be a direct causative factor, but it's still, there might be an implied association between the two. And in that case, you're trying to figure out this association. Then B1 is the coefficient for the independent variable, and it kind of says how the effect or how a change in x1, a unit change in x1, and we'll be talking about this a lot, unit changes. A unit change in x1, how that affects a unit change in y. So it's kind of, think of it as the translator or the multiplier or something like that, that connects the two, the connector between y and x1. So you can't just say, you can't always say x1 is directly proportional. There is, well, you can't just say y, the change in x is always equal to the change in y. There might be this coefficient of proportion, to which proportion that change is inflated or deflated. And b0 is the constant, so it's a constant term, and we'll talk about the constant just in a few seconds. So now let's look at the simple linear regression, because it's the easiest one to discuss. It's very pretty straightforward. You can visualize it quite well. So here we've got the y and x axis. Let's look at that specific example where we have experience and salary. So experience is going to be our horizontal axis, salary is our vertical axis. And we want to understand how people's salary depends on their experience. Well, what we do in regression is we don't just come up with a theory, we look at the evidence, we look at the live hard facts. So here are some observations we've had. So in a certain company, this is how salaries are distributed among people who have different levels of experience. And what a regression does is, so that's the formula for regression. In our case, it will change to salary equals B0 plus B1 times experience. And what that essentially means is just putting a line through your chart that best fits this data. And we'll talk about best fitting in the next tutorial when we're talking about ordinary least squares. But for now, this is the chart, this is the line that best fits this data, and even looks like it, right? So it's quite hard to draw a line that fits this data better. And the assumption here is it's impossible. This is the best line that approximates this data. What does that mean? Well, we'll talk about that in the next tutorial once again. For now, let's focus on the coefficients and the coefficient and the constant. So what does the constant mean here? Well, the constant actually means the point where the line crosses the vertical axis. And let's say it's $30,000. What does that mean? Well, it means that when experience is 0, so when, as you see on the horizontal axis, when experience is at 0, then in the formula on the right, you can see that the second part, B1 times experience, becomes 0. So salary equals B0. That means that salary will equal to $30,000 when a person has no experience. So as soon as somebody's fresh from university and joins this company, most likely they will have a salary about $30,000. There will be some confidence intervals there, but we won't go into that right now. Just we can say that according to this model, that person will be probably getting paid $30,000. Now, what is B1? B1 is the slope of the line, and so the steeper the line, the more you get, more money you get per extra year of experience. Let's look at this in this particular example. Let's say somebody went from, I don't know, maybe 4 to 5 years experience, right? So then to understand how his salary will increase, you have to project this onto the line and then project that onto the salary axis. And you can see that here, For 1 year experience, the person will get an extra $10,000 on top of his salary. So if the coefficient B1 is less, then the slope will be less, and that means the salary increase will be less per every year of experience. If the slope is greater, then that means the experience will yield a more increase in salary. And that's pretty much it. That's how a simple linear regression works. So the core goal here is that we're not just drawing a line theoretically that we came up with somehow. We're actually using observations that we have to find the best fitting line. And what a best fitting line is, we'll talk about that in the next tutorial.